Hi, this is Jagdish, Assistant Professor of EC Department, SMS College of Technology, Coimbatore. Today, in our video lecture series, we are going to discuss about the maximum power transfer theorem. It is one among the theorem in the network theorem, which is we are seeing in the unit 2. Come, let's get into the topic. What is maximum power transfer theorem? So the maximum power transfer theorem is the one of the essential network theories. The maximum power transfer theorem helps us deduce the maximum external power generated with a finite internal resistance in an electric circuit system. Maximum power transfer theorem explains that to generate maximum external power through a finite internal resistance, that is a DC network, the resistance of the given load must be equal to the resistance of the available source. In other words, the resistance of the load must be same as Thevenin's resistance. So, according to the maximum power transfer, in a simple manner, if the load resistance and the internal resistance both are equal, the internal resistance here we are considered as a RTH, that is a Thevenin resistance. When RTH, which is equal to RL, the maximum amount of power will be transferred from source to load. This is actually a maximum power transfer theorem in a simple word. So, in the same thing, in the case of AC voltage source, maximum power is produced only if the load impedance value is equal to complex conjugate of source impedance. As shown in the figure, a DC source network is connected with variable resistance RL. So, when this RTH when equal to RL, so we can have a maximum power transfer from source to load. So the fundamental maximum power transfer theorem formula is P max, where P max is nothing but of maximum power, which is equal to V Thevenin square, that is the Thevenin voltage, by 4 into RTH. So RTH is a Thevenin resistance. So the maximum power transfer theorem aims to figure out the value RL such that it consumes maximum power from the source. That is I equal to VTH by RTH plus RL. Because I equal to V by R, here we have two resistance, RTH and load resistance. So we have to add, since these two resistances are in a series, we have to add these two resistors, RTH plus RL. So the total power connected to the resistive load, which is nothing but of PL equal to I square into RL. That is I here is nothing but of a VTH by RTH plus RL into whole square into RL. So PL can be maximized by adjusting RL. Therefore, the highest power can be generated when dPL by dRL. So that means difference in the load resistance will give the difference power, that is equal to 0. So, but here dPL by dR, which is equal to 1 by RTH plus RL whole square into whole square. So here we have RTH plus RL whole square into d by dRL into VTH square into RL minus VTH square RL by d by dRL into RTH plus RL whole square. So this which gives the dPL by dRL, which is equal to 0. So here VTH square into RTH minus RL by RTH plus RL whole cube, which is equal to 0. So RTH minus RL, which is equal to 0. So RTH equal to RL. So the highest power transferred to the load is P maximum, which is equal to, when you substitute, when you simplify the equations, derivations, finally we will be getting the P max, which is equal to VTH square by 4 into RTH, where RTH and RL are equal for the maximum power. So the presence of linked sources enables the network to be active. So the maximum power transfer theorem is applied for active network and passive networks. So the maximum power transfer theorem can be implemented to the linear networks, the network system along with RLC and restrained linear sources as elements. Maximum power transfer theorem functions only when there is a variable load. If not, choose the least available internal source of impedance which paves in the maximum current through the fixed load. So large sound system are built around this process. Maximum power transfer is generated in the circuit by making the speakers loud, that is a load. Speaker is considered as a load here. resistance is equivalent to the resistance of the amplifier. Once the speaker and amplifier have equal resistance, both are considered harmonized. So another application is on the relationship between the starter motor and battery of a car engine. Power applied to the starter will rely on the effectually resistance of the motor and the battery resistance. When their values are equal, the highest power is transmitted to the kickstart the engine. So these are all the applications of the maximum power transfer theorem. Thank you.